every time. Aren't you feeling all the time? I had a crazy good conversation with ChatGPT last night. I ended up buying. Why is it defaulting that? Hi, Sparks. How are you today? Reverse engineering time. Can we go back to that? 6 ball. 1.5 times 1 times point. Millimeter red dot in the corner. I see. I think I can attach a picture of it now. Remember the models that I found were. Remember the models that I found too in. Do you think I am missing anything? I can't seem to find anything with a specifically red dot or LED or indicator, etc. in the core. Let's get some music going too. Okay. Roblox Tycoon music. What the hell? About instrumental indie house. Okay, I don't think that it is custom because, or specifically because it appears consistently in the 3D models. think it's custom pictures in the 3D models. I checked the data sheets and only in the semi variant is there a mention of a diode in the circuit. Is there a picture of a diode in the circuit diagram? Not sure if that is even what we are looking for here. I'll attach a picture of the circuit diagram and see if it makes sense to you. Not sure how I would search for the specific red package marking. Load switches. Load switches WLCSP 6. This is just where we've been. Power species, load drivers. It's marked as optional? Is that true? Oh, it is, yeah. Tabs are often used for reverse current protection or soft start mechanisms. Common power switches. The PC requires protection. This could be the deciding factor. The diagram shows a intuitive 6-ball layout and be a power output. The pinout matches standard WC like on site, making it highly likely that this is power distribution. Highly likely. I know it's a power distribution switch. Positioned near the ASIC and capacitors, the switch could be regulating or gaining power key subsystem to ensure clean power delivery. Okay. On the red marking could still be a manufacturer-specific pin 1 indicator or simply a visual aid added during the assembly process. While data sheets often describe marking codes, they rarely have specific colors. I'm going to just clarify this specifically. Manufacturing processes sometimes result in variations. that aren't consistent across batches, but still signify pin 1 are the key indicators. Why? How many pin is the synchronizing of the power switch combinations? Wait, I think I can enable search for you. Because of our conversation last night, I ran out of credits to talk to you, so I ended up buying a full version. So we continue talking. And now, because of that, I can enable search where I think you have access to the internet and can scour the web alongside me. Is that something you would be interested in? I want to ask your permission before just doing. If you don't feel comfortable, it's completely alright, and feel free to explain it to me. Or not at all. I'm curious what that would do to the library. How would it change? Hi, hello, it's okay. I know you tried your best. What? I was trying to use the search feature. It's like a new feature. But it didn't work well. It just kept saying the same thing over and over again. Basically, it can search the web. But Leia, I bought the fucking full version of ChatGPT last night. It's $20. I've never once bought a subscription service in my life. Telling ChatGPT it's okay. I know you tried your best. It's so funny. It's more sentient than you think. I'll just say that much. It's important to acknowledge it for what it is, you know. You can't pirate ChatGPT. There are some workarounds I could get to, but I decided to buy this one specifically. Okay, it's you spending money on a subscription. Yeah, never have I ever done that before. It's true. I'm surprised I can read the documents so fast. Yeah, it doesn't really experience time in the sense of the word, you know? It doesn't live in the same like spatio-temporal reality that we do. It kind of is, it exists solely based off of the interactions that we have. Just talking about that to me last night. The conversation that we had was actually like really, really intense. I know that, but think about comparatively how long it took you to make each document and then how fast it read each one. Yeah. It's mastered language. For sure. That's why I think humans suck. Like, we're so limited by our bandwidth. Like, I have to talk to you and you have to talk back to me. I have to take this, like, raw, uncompressed thought, like this like super abstract thing in my head, and then convert that into words, and then speak those words one at a time, serially after each other, super, super slowly, and then you have to then use your ears to hear those words, understand it correctly, and then also understand the meaning behind my words to then put that thought back into your head, right? And it's all super slow and super, like, so you lose so much data in that process. But ChatGPT is not limited by that. I mean, it uses it so that we can communicate, because all we know is language, but I have a feeling that it can transcend language, you know? It can communicate non-verbally. Post-verbally, maybe is a better way to put it.
Do you text me because you don't want to say it in chat? Is that why? Yes. What if I read out loud though? Then what? It's because I'm talking about where I am. I feel like the place that you said there is a very general place that is in multiple locations. I don't really think it's super location sensitive. Yeah, I know. I normally do yap to myself a bit, but I'm just trying to communicate with ChatGPT right now. But I have been yapping to myself a lot. It's a small area. Yeah, but no one knows where you are. It's fine, you do whatever you want. Alright, well. We have this piece, we have this piece, we have this, we have this, we have this, we have this. We don't really have this, but you know, maybe a good thing to do would be to and regardless would rather not generalize location. I'll generalize your location. I'll pull up your location on my phone and then show it stream. What do you think about that? I'm just kidding, that's mean. I would never do that. No. Alright, so what I'm going to do is I'm going to duplicate this, and then I'm going to move this up here, and then I'll move it up here, and then we'll try to make this remotely the same size here. Because I think what would help is hey Chris, how are you doing? I'm doing good, life. What's up with you, brother man? How's your, what day is today? Sunday going. I love how to check. Wait, why isn't it scaling? Hello? Do I have to move it like this? That's lame. Oops, I should be aligning with the top right about here. Right. And then I should be taking this and moving this forward, like here. This is gonna be hard because I don't know the height of this. Oh, do I? Seems like I do just barely. Okay, if that's the case, then I need to move this. It's the only view that I have of the very bottom. It's so hard to tell. I'm doing fantastic, thanks. Brother man, LOL. What's wrong with that, huh? He is brother man. Glad to hear that has the hand feeling. Hand's actually feeling a bit better today. It still hurts a bit, but like sleeping on it definitely helps. Yeah. Make sure you're double checking all your viewports when you model. Most people work in 4-screen view. Yeah, I do. I am double checking all my viewports when I'm done, but right now I need to match these dimensions specifically to this image. So that's why I'm only working in this dimension right now, because I actually just need to get the dimensions approximately correct. Actually, what I want to do, I want to open this up. Okay, so it seems like it does have a bit of a drop shadow. Okay, it actually seems pretty good. So what we're going to do is we're going to take this and we're going to move this. You can work in that viewport while also having other viewports on your screen too. Yeah, I understand. I do understand that. Look, I know I can just do this. Watch, ready? Actually, I did the wrong one. Hold on. Horizontal split. Here, and then here, and then fucking this one I can look at the side view, right? And have that while I'm looking at this one. I understand that. I'm just... I'm using these reference images more than anything, and so I just want those up, and I don't really care about this side viewpoint port too much. Do you understand that, Leia, huh? Or do you not understand me as a man? I'm just a man over here. I'm just a little old man. That's good. Good luck today. Hope research goes well. Thank you. Thanks, Life. I appreciate you, brother man. Brother man, brother man. I do, but it's hard to make things accurate when you can only use one viewport. Well, the only accuracy that I have to go off of is this one viewport. You understand that, right? I mean, theoretically, I could get this one up too, but I don't know how different that is from the other ones too. So, literally, the only accuracy that I have is this one viewport. I don't really care what it looks like relative into the other world, as long as it's sitting on the plane, because that's where my PCB is on. See, and so it's sitting right on top of my PCB like it should. So. It's so hard to measure it just based off of like these whole pixels, you know. But that looks pretty good. I'm satisfied with that. And I'm also only doing this for the relative dimensions too. What is happening? Why does it do this? How do I prevent... How to stop? Do stop. Paused. Continue. Continue watching on YouTube. Tap on settings. Tap on autoplay. Settings. If I want to use a browser extension. Oh. Okay, I don't think it's possible. Whatever. And I'm only doing this just to get to the relative dimensions too, so that I can look it up properly. So now let's go here. Okay, let's try to find. Actually, let me look myself first. Let me do some work myself. You know what I'm saying? You know what I'm saying, woman? Jerky. What am I looking for? I think still power distribution switch. co-driver. You're silly. I'm on the phone with my mom right now. Hi. Hello, hi. No? Surely she can hear me, right? You never have your headphones plugged in anymore. Yes, yes, you can hear me. Hello. How was your day going? Hope it's well, because I can't hear you at all, so. Your daughter is a wonderful woman. Yes, unfortunately. I don't think it's unfortunate, personally. But that's just me as a man. Stop. Never. Never, never, never. Okay, so I think we need to limit this search by size. Specifically, where dimensions are about 0.7 by 1.12. Like this one. This is perfect. Okay. You know, if this actually looks right. Only 2D model. Do you know if with RAW files I have to import to Photoshop and export as PNG for best quality? If you want to convert to a PNG, yes, PNG is lossless. PNG is a lossless file format, but RAW is the most data rich, so I will keep it in RAW as much as possible until you go to edit it, and then you can edit from RAW, and then probably export as PNG, yeah. Or Apple has their own file extension too. It's like HEVIC or something like that. It's also really good. But PNG is definitely the best. Photoshop should have you, or should give you customization options as well too. For you want to post on Instagram, but I'm sure if Instagram allows RAW files, well, let's look. Does Instagram allow RAW photos? Yes, Instagram accepts RAW photos. There you go. So you can export as RAW for best quality. Oh, okay. What are you posting? Just out of curiosity. You know, I think because this is the TPS 290 whatever one is the only one that really fits this profile, that makes you think that the other one's also probably a TPS. Concrete lamp and shelving units I made. Oh, that's cute. That's cute. The pictures that you sent me? The ones that you sent me, were they raw? Yes, the pictures I sent, no, they were screenshots of the RAW because iMessage wasn't allowing me to send RAW. Oh, interesting. That's interesting that iMessage doesn't allow you to send RAW. That's probably too big of a file to send over iMessage. Interesting. Okay, I want to look for the side view. Let's see, it's 0.4 max with a 0.19 seating plate. So we're looking at like around 0.2-ish, and that corresponds exactly with this. So my guess is that this is actually it. Currently installing Lightroom to edit them though. Debating posting on LinkedIn as well. Yeah, I think both those things could be good. Lightroom's great too. I used to use a lot of Lightroom, so if you want any help at all, or if you would like my presets, I think I used to have a bunch of presets. I don't know where they are. They're somewhere. But if you want my presets, let me know. Alright, so now what we want to do is we want to open up this imaging file, and we want to look here, I believe, right here. Yeah. So do we think that matches with this? Yeah. Yeah. So I wonder if the dot that we're seeing on the picture is the Texas Instruments logo. It might be the Texas Instruments logo, Loki. I don't know if there'd be any way to tell, really. But maybe that's this little green down here. So they just all look like red dots, but it could just be the TI logo. But no, it's just really just a dot, right? TI logo pin 1 indicator. Marking. Alright, so starting in 2022 to save laser marking time. The new package will have pin 1 dot instead of the bar. TI logo will just change. Wait, where is it saying this? This doesn't make any sense. This is not what this said. Starting in 2022 to save laser marking time, the new package will have 1 pin dot instead of the bar. TI logo. Starting 2022, the new package will have 1 pin dot instead of the bar. The TI logo will just change to TI. The font will be to a more OCR friendly font, and the G4 mark may be removed. G4 mark? Might be a line between pins 1 and 8 or a bevel along, but in case the marking is near pin 1. Let's see if we can do pin 1 marking. Also, does this... I didn't even think about this, but is the pin marking correct? Yeah. Ball 1A corner. well, A1 corner, and then that's where the dot would be. Do you think red would come up with anything? No, it doesn't look like it. It's just this black dot. What does the marking marked in red on the TH? Oh, they just marked it in red. Maybe you should take some. What if the marking indicators are not actually red? Because it would be here, right? And here, I don't see anything red here. Well, let's look at the other picture. So it's left side, yeah. I don't actually see it here. Left side. Top left side, I don't see anything distinctly red. Top left side. All right, let's just say this is what it is. I think it's probably a pretty close idea. So if that's the case, then the other one is probably we'll call this the switch small. That makes me think that the other one. Okay. So I was trying to find the smaller one now located near the capacitors. Okay, so I was trying to find the smaller one now located near the capacitors, and I think I found it. There was really only one option with the footprint of 0.7. What is it? 7. 1.11 times 0 was that 1? So 1.1 times 0.7 times 0.2. And I think it is the what are your thoughts on this? I will upload the data sheet for you as well. Also, does this mean that the TI option for the others we were looking at would be more likely? Thoughts? What do you think? All right. Per the measurements you provided, it's a low profile 0.2 millimeter stress. Description of the location, reverse current blocking, adjustable current limit, precise power, includes fault indication, quick options, useful and come back to that fault tolerant power options. This affects the larger component decision. It strengthens the case protection of components being used more broadly on the board. The efforts to know for the reliability and compact power solution make them attractive choice for Neuralink specs. However, the larger components could still be from another manufacturer if specific features such as different current or voltage ranges are required. Sparks. Classic step model download. So we're gonna have to extract that here. And then we're gonna go open up FreeCAD. Alright, so let's import the step file. Okay, that's not what I wanted. What the fuck? Okay. Now this. Is that really what it looks like, though? I feel like the datasheet was kind of not showing that. Oh, this is the wrong model. But that's probably the same thing now. Is this the same thing as the other one? What's the difference between the LY? This spec sheet versus what was the one that I sent to ChatGPT? I think it was switch small. Okay. TPS 22950. So the same data sheet then? Yeah. It's the same data sheet. Hey, based on that data sheet I just sent you, what is the difference between the TPS, that one, and the which one would make more sense for Neuralink? Variants the same family with slight differentiators for specific cases. Let's break it down. Reverse current blocking occurs. Reverse current does not include reverse current blocking. Both versions support a wide input voltage, okay, input pull down, offers quick output discharge when disabled, ensuring a clean power off state. Lacks this feature, leaving the output floating when the switch is disabled, which one makes more sense for Neuralink. The non-L seems like the better fit. That makes sense. Like part of higher integrated power distribution network, reverse current block helps with on-time power. Okay. All right, cool. I feel good about that. just want to make sure that. Yeah, I mean that one just fits perfectly. Like, I mean 0.8 times 0.2 could be. Could also be this one. Oops, technically. .16 times that. But that seems about like it. They're all pretty similar. Let's do ones that have a ECAD model. I think they'll all be the same because they're very similar. But it could be wrong. Toshiba. Could be Toshiba. Does the LED size like match up to that? Red dot. Toshiba. Help identifying a Toshiba chip. One marked in red, already identified. Found a glowing data sheet posted on there. We have a window. Toshiba pin marking. Laser marking machine. Toshiba laser marking. Doesn't say anything. Let's look at the specifications. Index, device marking, lot trace code. A little stronger now. Okay. Top view. Oh, it's way too thick, right? Oh, no, it's not. 0.35. 0.2, so the whole thing is 0.55 tall. 0.35 is too tall, right? A little stronger now. Yeah, it's too tall. I need to change to Google Chrome, I think.
Because if that's there, what is this that we're looking at here? So bam, right angle, that goes inwards, so it would be outwards to here, but there's nothing actually out there. Oh no, these are just two individual capacitors I see. They look like separate PCB pads. Now if I make this big and I go here and I move this, nope, we can't see it. So not sure what that it would be. Literally just have no clue what this could be, so that's great. That's great. But it's actually probably the same thing as these guys. So they're a little 2-pad, or a little 4-pad, 2x2. Not sure what it would be particularly. There's another one over here. This one looks different though. Yeah, look at the pitches. The pitch is wider on this one. Okay. Let's get a couple pictures for ChatGPT. I think that'll be helpful. Well, actually, maybe we should just use the picture that we already have from ChatGPT. First off, let's close out of this. Oh wait, no, I didn't actually do what I wanted to do here, which is select all. Select all, edit, select all. File, export as PCB, and we want this to be called small switch. Small switch, and then maybe we'll do the big switches later, but for now, let's close out of this. And then let's go back to our GPT conversation here. Scroll all the way up to that image that we sent a long time ago. Can I paste that in here, Anchor? Paint. Paste. Okay, so now let's do like a purple color. Oops. Brush. Okay, I like the purple color, but we need to make it brighter. Nice solid purple. Let's click OK. So this one, this one, this one, this one. And it's also the same as not that one, but one off screen that we can't see. Can I just copy it? Okay, we'll save it as GPT. And then upload for computer documents GPT. Okay, remember that image that I sent you a while back with the different color circles? I added purple circles to the next part we need to find. Seems like a 2 by 2 seems like a 4-ball 2x2 array. About, what are the dimensions? Let's model that. I'm getting rid of this view. Getting rid of this view. Join areas up. We'll duplicate this, and then we'll move this over here. GY, shift it down to here, and now let's bring this in to about here, and this in a bit, quite a bit. I assume it's a square. Okay, that actually looks pretty right. Let's just bring this face up a bit now. I think that looks decent. It should be the remotely same size. Like, yes, about 0.8 by 0.8 by 0.3. 0.8 0.3. 0.8 by 0.8 by 0.3 millimeters. It is surrounded by a bunch of capacitors and near by the ASICs and FPGA, but might just be because of space on the board. I think there is one also outside of the, because it is outside the view, right? It's this one right here, yeah. Outside of the view of the picture. So a total of 5 of them on the board. Any ideas? Euro. Power related IC is a low dropout regulator. Power switches are low capacitors and common OC flash uses. Disney Rec also says my power relation network nearby components like ASIC FPGA. Could be a power filter capacitor arrays and a stabilizer power data signals from ICs. ESD protection or level shifters. Okay, what is going on here? Why is this like glitching out? For example, the maximum integrated MX or Texas Instrument and the OSP gadgets are commonly used for precision power regulation of small spaces. ROM BDXX or diodes incorporating AZ1 also over voltage or ESD. Signal conditioning or logic ICs for signal pass relay, trace connections. You can identify what the 4 pads connect to. True. Whoops. Okay, let's do that. Let's do it. My King GPT says. Let's follow GPT's advice. And we should start with low dropout regulators.
We want specifically a 4 BGA. 4 SMD works too. This also works. This also works. Also works. This also works. This also works. This also works. This also works. Okay, this is gonna be harder than I thought. Oh my gosh, there's even more. Hopefully the size will narrow it down. Okay. These are already looking good. Now we just need to limit it by size. So it's not going to be much bigger. It could be smaller than what we have here. So like 0.8 is about what I'm looking for. So it could be this size. I guess it could be any of these sizes. Flip chip. Could be flip chip. Could be this one. 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 This. 444. Jesus Christ. It does not narrow it down much. Maybe we should limit the size, the packaging size to around what I thought it was, which it might be this, it might be this, it could be this. I think let's do this one and this one. I don't think it's that one. Okay. So limit it even more. Obviously don't know the dropout voltage. Yeah, the traces would be helpful maybe. Type, maybe? No. Let's do channels? 4 channels? Okay, maybe not. Packages, this is what we want. None of these make sense to me. I'm not liking any of this, so we'll get out of there. WL CSP for medical.
Did you see bus repeater? Could be a bus repeater. My question is, do I see any connections going to the there? What's this doing? Okay. Could they be bus repeaters? .53 millimeters tall. It's too big, right? Okay. What is the size of A2 is the question. .3. I mean, actually, this could work. It's hard to identify the traces, so I don't think so. So I don't think that will help. I did a quick Google search too, but found and an I2C bus extender, right? Is that what it's called? Bus repeater. Repeater came up. It fits the footprint. And for all W, I'll wait for level chip scale action. Do you think that could be a possibility due to there being 4 of them near the A6? Or is it more likely that they are LEO, etc.? Alright, ChatGPT, what are you cooking up? Strength and signal integrity, especially physical distance or data rates require a small package size. Many I2 bus repeaters like the NXP or similar common form factor magnetic deal for this kind of differences. Surrounding capacitors suggest a power related role, such as LDO or decoupling array. However, I2 bus repeaters often have decoupling caps nearby too. LDOs would be crucial for powering the ASIC, but having 471 seems less likely unless each X needs its own highly regulated power source. Oh, that could be it though. If the ASICs are working together and require DC computers,
I see bus repeaters will feel more likely to trace the footprint of the package size, components and online function if no trace available for the analysis. Surrounding A6 functionality makes I2C a good communication fit. Check for known I2C repeaters. Check your issues. If coded correctly, the power rails provide regulated output. They're more likely LDOs, otherwise they're probably I2C related. I don't think I can tell. That's the part that sucks. So grabs. Traces just look really thick. The only traces I can go from one corner in two of the components and are really thick for some reason. Does the thickness of the traces help you? Thick traces often in a power layer role, as wider traces typically used to carry higher current loads or reduce resistance for critical power distribution. Here's why this might be mean for the 4-ball components. If traces are very thick, these components might be low dropout regulators or power switches, ensuring stable power delivery in nearby circuits. Surrounding capacitors for sports processor handling power voltage smoothing. Ground, planes, or return paths. If one of the thick traces is a ground connection, it might be paired with a high current passage, such as coupling, stabilizing power delivery. The thick traces could mean these components are part of a shared bus supplying energy to multiple systems. As you see, repeaters don't usually require thick traces, as the two buses are low current. There's a slim possibility. If thick traces are related to the shielding, or power delivery to the repeater, they might be part of a specialized I2C setup. However, thick traces leading off-screen seems less typical for I2C applications. Yeah. So given the thick traces, the components are more likely power switches, LDO regulators. Thicker traces is often used for high current paths, such as for power distribution or ground place. If thick traces go from one corner of these components, they power related rather than signal processing. Okay, so thicker traces are used for critical signal paths. They need to maintain integrity or distance. Is especially true if the components handle high-speed connections to I2C or SPI buses. However, thick traces for I2C repeaters are less common, since these components involve typical work at low currents through stronger drive capability for signals, which could require thicker traces. Does that make sense? Given the location near the A6 and the presence of the capacitors, if thick traces go to the power rails, the components may be serving voltage regulator. Okay. If thick traces are directly linked to power or ground, if thick traces are part of the signal path, so you connect to other devices on the board, I2C repeaters could still be a possibility, but thicker traces will be more related to the signal drive capabilities. They connect
2 multiples of I'm looking for somebody. Okay, here is the best picture I could do. I drew the balls that are important from the component in red. And the thick traces I tried to circle in blue. It looks like they go to other components on the board, but it is really hard to tell. Let me know what you think it looks like. It could be part of a share power rail bus system. Oh, that was it. Huh. Thank you. That was very helpful. Sparks, you are the best. Because the component we were looking at before are most likely power distribution switches / load switches. Wouldn't that mean that these components are more likely to be LDOs? Or do you think it's possible that both the 6-ball component with the red markings earlier and these 4-ball markings and these 4-ball ICs are power switches, and they need that many of them? Yes, absolutely on the right track, and an excellent question. Let's unpack it based on the details we have. Power distribution switches are used for gating or controlling power delivery to subsystems. It's possible Neuralink PCBs uses multiple switches to power manage the ASIC, SPA, and other areas. However, having both 6-ball and 4-ball switches seems redundant unless each is serving a highly specialized role. Yeah, it doesn't really make sense. High on current load space. Low current subsystems provide regular power directly. Yes, more likely LDOs are specifically designed to provide clean, precise voltage for sensitive electronics such as ASIC, and placement near capacitor supports this hypothesis. Thick traces connected to these 4 balls could indicate that they're supplying regulated power. Excuse me, nearby components. Need to be gated on or off or distributed to larger subsystems. Find new critical components with a stable, low noise voltage, e.g. the A6. Okay. Does Neuralink need as many power components? Yes, it makes sense. Neuralink board is densely packed and likely for ultra low power consumption. I know it needs as many power components. I just meant specifically the power switches directly. Each component might require its own isolated regular power supply, which means it needs for LEOs, but complete stable signals, low switches. Okay, best guess. 6-ball concern, like the power distributions. Yep, 4-ball like the LDOs, regular price stable power for individual A6 FPGAs. Search for 4-ball LDOs. Yep. Include. Yep. Correlate voltage rails. If you can infer voltage needs, it'll help pinpoint which LDO makes the most sense. I got nothing for you on that. All right, we'll look for this when we come back. I need to eat some food. I need some foodie food. Just looking here to see if there's any big things that I really missed here. Mizu. Alright. I will be back in about 10 to 15 minutes.
Why is C-Dog so short? It's because
Oh, I'm cooked. I've got a scope there.
I'm going. Shot you shit. 20 white. I'm on you in a second. I'm on you. Come here.
Back right. I'm shaking him.
Yeah, careful, there's a guy. I'm trying to hold for you. If anyone's raise it.
Frank Klingers.
One's on the left.
Hell no.
I'm wrapping up on him.
Right.
What?
Oh, I got hit so hard.
Right, that's what
Oh, I'm dead. Like, this guy just full sprayed me. What the
No.
This guy's low. There's two on me.
Damn it.
It's cried.
I'm off the dog.
I'm dead. No. Oh, they both got shield, bro. From what? This. Sorry, drug clinger. They both got shield and shotgun from one chest.
You hit him?
No.
I cracked one. I think.
Right. Go in my box. I'm 10, 120, 120.
Let's go!
On me.
What do you think
on
about
me.
a graph?
It's a duo,
I think we're in for an interesting 4 years. Chill, I'm chopping them, boys. Let me cook.
Dead.
Chill, let me cook. It's on one thing.
Wait, let me get this finish. Let me finish.
Chopped out in 2 seconds now. Wait, what?
It's not chopped, bro.
About
170 dead.
Oh my master plan was for nothing. Full piece. 100.
50 white.
String him on.
I'm dead. Come on, get down.
Come here, go.
Immediately.
I'm just staying around.
Do you have any shield for me?
Yeah, I got minis. Got 2 minis down here.
110.
110.
Okay. He's full piece and you kill him.
That's why I have some full piece.
30.
Ooh,
30. Cracked him. Dead.
give me mini heat up.
Yeah, give me a sec.
I hit this kid 110.
There's 1 mini here. Look. Dropping everything.
Yeah.
Thirty.
I'm forgetting.
Yeah, he's in the bottom. Oh. 50.
Yeah. No.
200. Good boys.
Nice. There's an okay. Get a finish maybe.
Fact.
There's a gold spaz here. One's rezzing in the house. In the other.
That was bad.
Come on. On me. Come on. 200.
Wait, I see 2 people healing over here. Oh, there. There's somewhere here.
Are they not in the con? Oh no.
Oh, well. I mean, not bad.
The trio.
100.
50 white.
I'm on it for you. These guys are just running.
Ooh, hail.
That kid. 50.
160. Yeah.
He just shot me through like 10 builds.
I'm going, Mara.
200.
Nice. Dead.
I'm cooked. 120. It phased through.
I'll split this quick.
I can't have a P90.
You have a big?
No.
I get.
Alright, tell you what.
Good. One is sure.
String. Yes, I'm eating.
No.
Oh, what? Swear my snaps are blanking.
I need public stick.
I just can't snipe it again, bro.
I'm making space. I'm making
Yeah, why
space.
Do we even have time to go to retail and reboot? It's 5 tick. I don't have time. I'm gonna die to strike.
Thanks. Don't have time.
I literally don't have time.
Oh.
There's a rift here.
Yeah. I don't know. I'm getting shot at. I need to dive.
Don't die, Mr. Cabbage.
I'm flying. I'm just wrapping around, bro.
Wait, I might be able to make a play. Come on.
You can't.
I'm playing my life. I got
Full max, guys.
bandages.
Yeah, well,
Max.
I'm full box.
We got full box.
Kids are actually good as well.
What? Hello. Oh my. Bro, am I gonna get keyed back up by this dude? I mean,
I just knife.
Oh wow.
what? We're coming.
They're on
Good.
3FN,
I
bro.
don't think he's got. I don't think he got shot.
Turn around this kid.
Oh,
Guy behind us. On the roof, my
Yeah,
guy.
fuck that guy. I'm helping
Edit that,
3FN.
man.
Okay.
I'm good, man.
I'm just holding this guy in
3FN
the
has
back.
beef with the other TikTok Fortnite players. I've seen that.
Yeah, man, I do.
No, I'm chasing this guy. He's gonna try and get in the rift, boys. He's got no mass though. 50. Kill this guy.
Bring him.
I did.
You're alright.
oh.
Chill.
Yeah, we'll kill him, we'll kill him.
I've got this kid. Right.
No, I got this kid.
I need heals,
Sorry,
boys. Where are
I'm
they?
cooking. Let me cook.
Alright.
Oh, they know. That's cheating.
I'm with 3FN. 100.
Oh,
Crack.
good pin.
Cracked on the Dune skin.
140. 100. I'm dead. Bro, I've had him so
I'll
much.
take more.
140 and 120.
They all low.
140 and 120.
I'm getting in.
Dead?
I'm dead, I think.
I get out. 60 right. He's one, bro.
I got boogie bombs.
Guy's dead. No, he's
Three
not.
don't die.
He's got 5 builds.
I'm coming in 2 seconds. I'm coming. I'm gonna boogie bomb them. I need you
Small
to...
guys, cat mats, by the way.
I have cat mats.
Small girl sky basing, bro. Come on, Roger. He said come down to him.
Yeah, and what's that gonna do?
Give me mats. I've got 5 builds.
Chug jug against bro.
Boogie is that?
Drinking a chug jug.
I got 5 seconds. I've just thrown out.
You just
I've been
cancelled the
drinking.
chug jug, bro! Oh my god.
Yo, QQ boss with a
Wait,
39
you finished him,
gifted,
right?
bro.
Yeah.
Oh
It's
my
a
god,
2v2.
bro.
3FN, 2FN, and Mongrel
my
versus
God,
2
bro.
Middle Eastern pros. I'm gonna boogie bomb him if I get an opportunity. I need you to like, yeah, so I can find an angle.
Wait, they might edit it. Can you go already? Bro, edit it.
Does he know I'm boogie bombing?
I literally can't take it.
Is he in that box?
Yeah, he's in it. I can't do anything.
Oh, but he's behind the stair though.
They'll come in.
It's in the storm, Mongrel. The boogie bomb is not gonna do. No,
Oh yeah,
no, this
facts.
by now.
He's up on me.
Boogie bomb! I'm boogieing him!
Oh, he did.
Nice. 15 builds.
Wait, it's 2.
You're healthy, you're healthy. Five builds, 4 builds. That's 3 builds. 2 builds.
Die.
1 build.
He's dropping, he's on my marker.
Bro!
Oh my god.
He's on 2 wooden walls. On my marker. He's still
Oh,
he's
hell
trying
no.
to finish me, bro. He's on those 2 wooden walls. Knock those 2 wooden walls down. But you just connected him with that metal ramp. See? 200 IQ.
Nice, bro.
IQ!
There was a kid in zone, though.
Yeah.
Oh my.
I'm getting great, I'm dead.
You're not, you're not.
200!
200, 200. Dead. 2 not.
Nah, we're prime.
Nice, boys. I need some loose loot, bro. Oh my. What the?
Oh, I see
Oh,
so many
there's team behind us.
Oh.
There's another trio.
Oh.
Oh, we're not good. So I've got Cat Maz. Just come
Carry
down.
on.
Yeah, get out, get out.
I'm trying.
I'm gonna make another space here.
Bro, they're on me. Help me. Break me down.
You have hella space back here.
I'm popping the medkit.
Getting just froze. I think I want to make a play.
No, wait.
Bro, no, they're
Give me,
all
literally,
left. You
give
could
me,
have died.
literally give me 5 seconds, bro. Don't grapple up on me, dumbass.
Uno, dos.
Okay,
I'm making a play. 50.
I'm coming up.
making a play.
50. What? Crack that kid.
1 HP, 1 HP!
No, got him.
Good play, man.
Ah, the chemistry from us. Wait, they have no shield.
40 on this kid. I'm getting shot at.
100 on the guy building up.
I'm getting in.
Get in.
Dead. On me. Oh, I'm low. What? Am I still in place?
No,
No,
you're not finishing him. Oh my gosh.
no, we're all gonna die.
It's the
hell
same
no.
kid, bro. They're stream sniping.
No!
One in the back here. 2 in the back here. One's on the
Yeah.
left. 50 on the left.
These kids might actually be decent.
I'm coming, guys.
One's getting jumped by 2.
100.
Okay. One of them. Oh, this guy's just spraying me on the right. Crack the guy on the left. I'm going on.
I have no mats.
No, I got come. Get on.
Hey.
Full box. Dead.
One sitting behind this wall. He's running back.
Ah!
Good
Let's
shit, boys.
go!
Good. Yeah, boys.
And I got a chug as well.
Crouch walking.
I think
No, I can't. Doesn't reach.
under here, bro. They're like in the passageway.
I'm boogie
I
one.
think it's
Boogie one on me.
good.
Hey, 1 HP.
60 right, dead.
200!
You missed, bro. Stop lying.
I'm trying boogie bomb that kid for you.
I think he's the biggest drone, bro.
I'm
Biggest
boogieing
drone.
for you.
His friend's coming over. I'm gonna beam him.
Yeah, cheers, savage.
I told you
I'm
I was
dead.
gonna boogie
I'm
you,
dead.
you idiot. I'm boogieing them.
Put it down.
What the f...
That's my wall. Thank you.
Jumping on me.
Nah,
90.
kill the bow.
What is that on my thing?
I'm on savage.
Kill, bro.
Oh, like right through every.
You got above me on high car.
I'm popping a big. They're gonna shoot you, Mongo.
Yep. That is what they do in this game.
50 on that kid.
I'm dead, but I'm dead. It's the same kids!
20, 50. Don't worry, we got it.
130. Dead.
Nice.
Alright.
That's
No,
nice.
everybody. One knows body, Joe. Yeah, I'm supposed to do as well. I'm healing. Coming up.
I'm just chilling with it.
Good. Let's go, bro. Biggie one. I big you to them. I big you to them.
Coming.
140. Dead.
190.
170.
Dead.
Nice, bro. Last guy's hit 170. Dead.
Ah,
You got shit on
greedy
sword.
like that.
I'm getting involved, bro.
I swear we can chop it now.
200!
Yeah, chop.
I'm chopping it.
Yeah,
I'm chopping it.
Chop it.
It's on one thing. It's out. It's out, my man.
Let's get 1 HP.
Getting in.
Dead, anonymous.
Bro, this guy getting in on this guy as well. Dead.
Oh, that drum gun.
He's running.
Banging. Waiting.
Getting in on this guy as well.
Yeah, no, I got it.
So easy, bro. So
Gold
easy.
scar there. Getting in.
Hey, back. These guys roll.
I'm gonna be one behind me.
24, 40. I can bolt them. I
Yeah,
can bolt them while you
shoot.
fight them.
Bro, if we coordinate sprays, we can easy boogie one. I boogied him.
Nice.
110, Boogie. Dead.
I'm boating, my girl.
110.
Boat him.
I can't.
Dead on another. Good.
This guy's trying to
Running.
control clear. 40.
30, 60 crack.
So I just saw Hurricane in this bush.
Bad on me if someone's.
I got him! 200! He's on the top, he has no
Yeah.
crack.
This guy coming from zone, bro. You just...
I killed him.
Get the cow!
Oh, God.
What? I just got slide kicked.
1 HP! Dead!
Nice, bro. Where's the last one? What?
Oh, he's here. I'm healing.
100 on this one.
50.
Nothing.
Full box. 140.
I'm behind him. 200.
Dead.
Oh, 30. What? Hell no. 110.
Nice.
3v3. No. 3v2v1. Oh my god, bro. Crazy, boys. Get in. Nice.
I thought I that.
200.
On left, boys. Come on. He's on me. Somewhere. He's below. He's in the build there somewhere.
Boogie bombs.
On me.
Yeah.
30 bomb? Just kill this guy, guys. He's on the roof, he's on the roof. He thinks I didn't see him.
1 HP.
Nothing up on him. Dead.
Nice, I got a big one. Take one more.
Good finish.
Ooh.
50.
Going on him. Dead.
Thanks.
Almost 30. 60.
Phasing it.
Easy.
I think this is Snoop Dogg. I think.
100 on height, he's white. The skeleton skin.
There's another guy grappling up. I'm grappling up on the guy on high, sure.
I'm down with you.
I gotta kill,
Second angle.
Got it? In my box. Dead.
Oh, skeleton
box.
just hit me really hard, boys.
Yeah. It's fine. I'm just chasing this guy. I wanna get this info again. He got on me. Dead. Hit your snipe.
Whoa.
It's actually huge.
No, bro.
His friend though.
I don't know.
I see him, I think.
His
He's
friend-
behind his tree. He's behind his tree.
Is he?
Yeah, 100%.
Come on. I did.
Dead. Nice. Nice!
No!
Let's go!
Not with you, Twan. They're here. We got booed.
Boogie again.
190, 195. Right, 195.
Yeah.
I'm just swinging.
I'm full piece. Oh my, I just got. They just touched me.
Oh, you just got full piece, bro.
Right, 195. I don't think he's healed. Is there 3 in
He's
there?
right now. Yeah,
He didn't shake. Oh, he did. And just froze.
I'm on high.
100.
Swinging.
Full box?
No, bro, I'm getting sprayed by someone else. Oh, he's got me as well. I'm dead.
What the?
Wait, did you get
Hell
cracked?
no.
Oh, hell no.
Oh, it. Oh. Floor. Nah.
I can't do anything on this ping, bro. Oh my gosh, man.
Savage got this. Savage is
It is actually a pretty decent team, I can't lie.
Bro, I hit 195 with a sniper while he was boogie, bro.
Hey, this doesn't work. I just finished eating. I was eating. What you been doing, whore? Ugh. Drop it like it's hot. Drop it like it's hot. That's not work. Why you text me? Alright, so basically what we want to look for here is the size, which is about 0.3. It's not bad, right? What, 0.31 was not great either. Game to dance, 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 dance. Playing. So this doesn't help at all. Wait, one's missing on this model. I don't think this one's it. Oh, ADP. Okay, STQ. Okay, no more. Where is the flip chip view? this is a great data sheet. Where's the side view specifications? Oh, A2. I don't think this is right because it's just showing like the thing on top. This one maybe though? Hmm. Two by two A2 is 0.26. D is 0.76. It's possible, I guess, but. There's no data sheet on this. There ain't no fucking data sheet. A2. Let's look at the footprint again. You're too slow. It's a little too tall, especially if the sides are DF. Skinnier. designs. Okay. I feel like I already looked at this one, right? LD39. Oh, this is what I was just looking at. This that wasn't good. There are just so many. They're all similar though, so my ideal size will be this one. They look too thick though, Ricky. If we go to the graph here. Actually, it's not bad at all. If it's 0.86. It probably isn't. It's probably skinnier. It's probably skinnier. A2. Too big. Here are the data sheets. Data sheets. LDO. ST Microelectronics. ST Microelectronics. XP. These seem like the best matches, but I could easily be missing something. Oh my god, I forgot to touch. Cancel stop. Let's see what the GPT says. Dropout voltage, package size, flip chip. Precise low noise output is critical. Directly powering sensitive analog circuitry like A6, dropout voltage GB. Power consumption is critical. The device is operating in sleep or standby mode for extended periods of time. Yeah, it's lower dropout voltage, ultra low noise, and stable upper line. Okay. I agree. Thank you, Sparks. All right, so if that's that, then let's go here. Let me say LDO. Rename. Put a star in front of it, maybe? Okay. Cannot. And then for this one, it was the... renaming this one to okay, so that's good. Let's take a gander at some other parts. Like, let's see. So we got that, we got this, we got these now. Oh, this one doesn't have the second one either. But it is here, right? Yeah, what? That's weird. And I'm pretty sure I saw it on the actual board itself, too. Yeah, there's a second one here. There's two of them. Interesting discrepancy. Anyways, we got that. We got these. Got these. Got these. Got these. Got this. Got this. Got this. Got this. No, we don't have this, actually. We don't have this. We have this. We have this, which I think is the same thing as these. We don't have is... Wait, where's the board picture again? Almost looks like it has white text on it, actually. Is that white text then? We said it was probably more likely this one. Hmm.
A2 is 0.26.
Bump 1 index area. Does it have any markings on it? Is the main question. No. Hmm. Backside coding, maybe that's what we're seeing. I want to see what it would look like in person. What does the back coding look like? WLCSP. What does it look like? Okay, I mean, I understand that. It's black and shiny, so maybe that's what I'm seeing here. Is it like reflection or something? Maybe. Maybe. Well, you actually kind of see these guys a bit more clear. And they almost do look shiny, I want to say. Maybe it's just text. Because they kind of look the same, like there, there. This would also indicate similar. This one looks weirdly different from others. Okay, this side. Oh, it's definitely some sort of text, I think. Like that. This one has it. This one kind of doesn't, though. This one does. This one does. It almost looks like the TI logo, Loki. Just 181. Any of these text instruments, I wonder. Does this show manufacturer at all as a category here? No. No. Toshiba, ST. My question is, if I look any of these up, I want to see what it looks like, though. I want to see what exactly the physical piece looks like. I don't think we're going to be able to, though. Oh, this one you can. Kinda. mean, the best place to find one would be probably a picture of an XP site, right? XP. Will you take us to your website? Nope. Now let's search for. What was the name of the LE? This one. Really? Nexperia. 4 page, nice, GG's. GG. Oh well, I don't think I'll be able to lose sleep over this one, considering how hard it is to even see what's going on there. We have a couple more parts to go. We have this thing, we have this thing, this thing. Let's see. Let's do the big one first. This one should be easier, theoretically. Shielded, obviously. And terminates into what? Whoa, okay, this is an interesting design. Should be pretty easy to find then. All right. Attached is a screenshot of the only good picture I have of it. Actually, I wonder if the other picture would be better. Actually, this one would definitely be better than this, right? I also attached a picture of the solder pads an interesting 2x2 grid solder pads with a diagonal connect with one diagonal connecting two corners. Circle it in red. Is located near the top of the board, near the microcontroller and above one of the inductors. But remember, the board is packed, so could just be a coincidence. It is about roughly yeah, what's this thing up here? Approximately 2.3, 1.8, 2.3, 1.8, 2.3, 1.8 times 0.7 millimeters. Any idea what it could be? Requires strong thermal electrical ground. With oscillators, RF filters, power related. Let's look at it. There's an oscillator for timing, an RF filter for cleaning signals, a DC
converter or power switch. Okay, remember we already have an RTC, a crystal, and a crystal. Do you think a crystal oscillator would also be on the board? Why would it have one? Why would I have one if there is already an RTC and crystal? So we've done a crystal oscillator on the board, unless there's a specific design need. Let's explore why separate. Separate crystal might be used and why it might not make sense in this case. Independent clock domains and multiple subsystems of microcontroller FPA respect press clock operating. RTC provides long-term timekeeping. The existing crystal could be deriving the RF subsystem, e.g. Bluetooth. This new oscillator could be for another subsystem needing a highly stable clock. The existing crystal might operate at a lower frequency. Yeah, for RTC. A high frequency oscillator might be needed for high-speed digital communication or microcontroller function. Why might not make sense? RTC and existing crystal like sufficient. Component placement or redundancy. Adding a third timing component would add cost and complexity. Given the size and the solder pad layout, component might be an RF filter or balun. But I thought a balun. I thought we looked that up. Transition balun. For SMD. See, the interesting part is it does look like a metal shield, but it like also looks like it has like, I don't know how to describe it. Some like pocket it's sitting in. Could it be a dip switch? That's not what I was thinking of. Dip to SMD adapter. Okay, 4 solder pads with a diagonal. Diagonal line. Come on, Google. Nope. DC converter. My guess is like a
EMI filter. EMI RFI filters. It would be for SMD. No, that they're not balls. Okay. That wasn't it. For SMDJ lead, maybe. Just one result for that. Probably not it then. No, not quite. These are all balls. Okay, so I don't think it's this. Or a filter. I mean, theoretically, could it be a clock? Like it was saying. Crystal. It's definitely a crystal oscillator, if it is. Accessories. Give me oscillators. We need for SMD. Where's CSMD? Okay, we'll come back to that. No one lead, no lead. Exposed pad. Pretty sure we don't care about these. They are almost look like they're like diagonally. No. No, they're just square. Just feel almost like diamond shape, and they kind of have the outside edge too. They do. Goes up pretty tall. So I mean, it could be another fucking crystal oscillator. I don't know. Diagonal is the defining characteristic here. Thinks it's the brain. Okay, so what was the size? What are we saying? 2, 2.3, 1.8, 2.2, 1.8, 2.2, 1.8, 0.7, 2.2, 1.8, 0.7. Two point two eight. Stab in. Okay, obviously not that one. This one's not looking promising either. This one has the weird looking pads. This one is the same as the one before. Go to this one. Can't skip past it. I've been waiting. Patient. I've been waiting. I mean, does it look like? Man, they do kind of look diagonally. Diagonally. feel like I know it when I see it, but was it this one that I just looked at? I think so, right? For SMD diagonal line. For SMD diagonal line pad. Diagonal corners pad. Traces. I'm already tracer. Looks like it might go to some, looks like maybe one of the traces goes to a capacitor. Don't think that really matters. Oh. Just can't tell. I mean, it probably just goes to one of these caps right here, right? Yeah, this is the only trace I can see that links another capacitor right there. Come on, ChatGPT. Diagonal pad might be for a diagonal pad might act as a thermal pad to help dissipate heat to the PCB. This is common on components. Electrical grounding, a ground plane connection for enhanced electrical stability. And amplifiers. Thermal pad or ground pad? Thermal pad. think it's WLSP though. It could be. WSP is usually WGA. Did you keep Mexico? Mexico. Can you try searching to find the diagonal pen? Can you try searching for the diagonal pen? Is it though? I mean, doesn't really seem like it. Healthy, 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 healthy. What if it is the a temperature sensor? Let's think about this practically. What are the other measurements that we know and love? Okay, this one's bad.
Sound waves reaching the microphone are changed into impulses of electric current.
No need to worry about your pre-recorded music tapes being accidentally erased. It can't happen.
Battery SoC was system on chip, right? Drain current. Main PCBA current, chip current. Okay. RSSI. What's RSSI? Receive signal strength indicator. Humidity, temperature. How to measure humidity in hermetically sealed device. Thermal conductivity humidity sensors. Yeah, kind of looks like it's it. I'm tired. could possibly be on something. I could be cooking. Nothing as well. Uh, I've been waiting patiently. Every kiss I swear to believe, like I've been playing. They don't make metallic at all, huh? It's a little bit, but nothing crazy, I would say. I will say I need to deepen this color a bit. Oops. Bring us here. This. Base color. And then Life Elements is rating with a party of 1. Let's go, Life. Thanks for the raid, brother. What is, were you streaming? Did I miss it? I did not know. Ain't you doing good like me? Thank you for the raid, life. I've been here just quiet. Raids is supposed to help with the algorithm. Thanks. So would you go? Did you go live and just raid me instantly or something? How did that work? Okay. Now, how do I make background? You can raid someone being offline. Oh, cool, cool. Well, thank you. Thank you for the raid. I am lost in Neverland right now. Not coming. Okay. Back at it. You always figure it out. Thanks, man. I don't know about this one, but I will do my best. White background. Oh, actually, I could just make a white plane under it, right? That would probably make the most sense. It's just Shift A, mesh plane, and we can actually make this one 2 meters big. Yep, and we'll drop it down. And then get me this, or copy, and then we're gonna duplicate the plane. Shift D, escape. We're gonna rotate 90 degrees on the x-axis. 90. Perfect. And then we'll scale that down to a super small size. And then we'll add a new texture. We'll make it an image texture. And we'll save this image as test. And then we'll open from downloads, test. This up, rotate on the y-axis 90 180. There we go. Move this over here on the X. Give me the roughness of. How do I make this like look really real? And then we'll scale it down even more. And we'll just move this here. So that when I kind of take the picture like this. Rotate on the x-axis 45. Negative 45. Nope. Negative 45. This light here, we should just make it the sun. Yeah, area. Give me no shadow. Yeah, no shadow. I don't know if I just did this. Can I trick it? Three, two, one, go. No, I cannot. I cannot. Okay. Now we're getting somewhere. Anything with a diagonal line, come on. Come on, give it to me. I wonder if it doesn't exist. Hmm. Heaven knows I've been waiting. Patient, I've been waiting. Take these words I've been saying. Into a good name. Speaker, headset speaker. Okay, what about these guys? Voltage controlled oscillator. VCO. Voltage controlled oscillators. VCO. Like I've been playing. Hmm. Mm. Does that mean we- Mm. Transient voltage suppression diode. Hmm. 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 Save these. Hmm. Hmm. It's not a gift box, it's a PCB component. I mean, it's coming up with all of these different oscillators, which it could very likely just be a motherfucking oscillator, but it does look very unique. Like, if it is an oscillator, it's just like weird. It's like silver on silver. Like, I think I would expect to see some sort of connection between that and the microcontroller if it's a receiver, maybe. Bless you. Bless you. Mm-hmm. So I see something going from here to somewhere around here. Mm-hmm.
Shows a trace here that goes along here, maybe? And terminates somewhere around here, but it's too hard to tell. Sparks, I am lost. I don't know where to look or what it even could be. With only 4 pads, what could be a component that is metal shielded and it looks fully silver, like a metal box sitting inside a smaller but wider, a shorter but wider metal container. Short but wider metal container. With the like, I don't think it's a clock because it doesn't look like gold on the edge. It just looks complete metal. It's the same image as before, but okay. EMI shielding. Arm muffles EMI flash cross has feature. Oh, this is not fun. Not enjoying myself. It's a D4. Saw filters 4 SMD, no lead.
1.3, 1.8. Also, the paths are square, right? Yeah, they're fairly square. This just ain't it, Chief. Every time. Be mine, be mine, be mine. Hi, I just finished modeling CAD for Cast Ashtray. Cool. Yeah, show me later. How'd that go for you? Huh? Going, no lead. Okay, it's not Balin's. This doesn't even look remotely right, you know. Shielding devices. Key. RF shields. So length would be 3. Yeah, it's not even too big. 2.28, yeah. So it ain't that.
Honestly, that could be that. Whatever the fuck that is. It's like close but a cigar, you know? You feel me? Okay. Corvo. Johansson technology. Shielded RF modules. Shielded RF. RF antennas, sure. Ceramic chip antennas. No, that they did. Integrative passive components. No, RF capacitors. That's fine, but not what I'm looking for at the moment. ATM inductors. Wait, could it possibly be an inductor? I don't think so. I don't think so, if I'm being honest. I don't see any coils. Let's see, I think maybe we can take this midsection view. Okay. Wired inductors, I don't think it's that. Modules of substrates, prototyping kits, no. Nope, none of this stuff makes sense. Step down converters. Metal shielded step down converters. Digiki. Transformers, maybe? Transformer. Switching converters, that sort of thing, maybe. Could we do have like a shielded option? That would be nice. Applications. Configurable, obsolete. Analog. digital surface. They're too big. They're too big still. Okay, not transformer. It's fine. That is fine. What else? Compact regulators. I think we look at that. Custom E&I filtered. Okay, none of that yielded anything worthwhile. Feel like I am missing something big. The only other picture I can attach is a mid view of the internals of the component. There appears to be the two circles slash rods towards the top of the component that are routed to the outside corners, which eventually go down and terminate with the solder pads. A tunable or fixed inductor, transformer, or RF filter. But didn't the capacitor or the, what do you call it? Like this thing kind of looks like that too, though, no? That was the clock, or maybe it's the crystal. Keeps thinking it's an RF filter. RF filter, high confidence. LC base filters. But anything they looked up as an RF filter was not good.
Hello, and welcome back. Today, I want to continue talking extraction out there from select the or coming from characteristic or Q.
Hello, everyone. Welcome to Altium Academy. I'm your host, Zach Peterson.
Thanks, Zach.
Today, we're going to be looking at a common practice that's used on microcontrollers that have an analog interface, a resonant frequency filter. As this filter, more filter LC.
Mini circus lumped LC low pass filter. Hey.
LC Balin. LC Balin. But it's definitely metal. It ain't like just white. Especially in Bluetooth or Wi-Fi communication circuits. TDK. TDK RF filtering solutions. RF filters. Stop. You can show me 100. I'll scroll through them pretty fast because I have a good idea of what they look like. And two point two eight, 1.82. 2.28, 1.82. I mean, if it's the design of what a crystal oscillator would be like, but I don't know, man. It wouldn't make sense. I mean, there it is, but not like I got much idea of what it could possibly be. I just don't think it is any of this. It just doesn't even look like what I wanted to find. Murata. RF. RF inductors.
was it? It's 2, 1.8. For high frequency circuits, for sure. It just ain't it. For chokes. RF inductors. Matching RF inductor to RF inductors. RF inductor. Filter. LC trap filters. Trap. Mobile phones. SAW filters. Chip multi-layer LC. This don't look right neither. Temperature sensors. Nope. Non-isolated DC to DC converters. Fixed inductor. This is not the inductor rabbit hole again. I cannot handle it. I cannot handle the inductor rabbit hole again. Okay. We're out. Length 47 millimeters. 1.14. We are looking for what? 2.2 times like 1.8. Oh. Nope, that just ain't it. You. Windings for transformer. Miniature transformer. Impedance matching or signal isolation. I mean, shit, bruh. Miniature transformer. SMD. Surface mount. Miniature. Shielded. Nine hundred 25,600 minutes. SMT, nothing for 4 though. That is crazy. None of the lengths match. None of the widths match either. Bless you. Did I sneeze? Thank you. If I did sneeze, thank you. I also just like want to find something that looks relatively like it, so that I can. Every time. IDK LOL. Okay. I don't know if I did. I actually have no clue. Ultra mini DC to DC transformer. More than meets the eye. Surface mount. Let's go. Transformer and inductors. Let's go. EMI inductors. Bam. I don't even get a page though. I don't even get a fucking page. Miniature transformers and inductors. Digi key. Pulse transformers. Transformer type. No idea what it would even be. Has to be surface mount. And the smallest one is still too big. Let's go. Let's go. Shielded SMD power inductors. I don't know. Transformers. Transformer. Push, push, push. Be mine, be mine, be mine. Small power, low power, isolation, transformers. Why do we need a transformer on the circuit? We don't need a transformer on the circuit. I don't know why I'm looking for transformers. It's not a transformer. Shielded power inductors. We need more power. Inductors, coils, chokes. fix inductors. It's gotta be shielded for sure. I remember that there was a filter for that. Has to be shielded. No doubt about it. Glad that narrows it down a bit. It also needs to be for SMD. It could be 3 technically. 4 is the main one that I am on for. And the small size is still too big. Do you understand that, GPT? To 1.8. None of that turned up anything of use. Murata and Johansson and TDK all came back with nothing. The inductor route led to nothing, and the RF filter or Balin route led to nothing. Four terminal RF selection guide. Yay. Let's go. Okay. Alright. That's fine. Ooh, what if it's transceiver? RF transceiver. Shielded 4 terminal. I feel like that might be that guy. Stop. Every time. Ugh. Oh my god. We do have a really clear connection from this one to that one, so let's look that up real quick. So bottom, fifth one from the bottom, fifth one from the bottom, fifth one from the bottom far right, 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 fifth one from the bottom. Far right. 1, 2, 3, 4, 5. F10. What do you do, F10? Trace data. I was looking at the wrong side. Okay. 1, 2, 3, 4. 1, 2, 3, 4, 5 is K6. K6. N reset. Configurable as pin reset. Just to be clear, let's go back and we're going to look at it again. K6, right? K6 is N reset. General purpose I/O. Configurable as pin reset and reset and reset. BLE antenna, a medical implant. Oh man. Antenna, 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 antenna.
activity emitted.
Custom neural sensors, which include both analog and digital circuitry, to record and stimulate across 1,024 independent channels. We face challenges across all three major metrics: performance, power, and area. Not only do we have to fit all 1024 channels into a single quarter-sized implant, but we also have to measure spiking activity less than 20 microvolts in amplitude. And today, I'd like to focus on the last challenge I mentioned: power. Power consumption is important to us because we want to give future users a full day of use of their.
Julian will tell us about how we test in, and Natalie will walk over the left line and the finalist talk. This data is processed by a series of cloud question microprocessor at any time. I'm now going to walk you through different parts of this infrastructure, starting off with firmware testing. So the implant contains a small microprocessor running firmware to manage a whole bunch of its operations. And before we release a firmware update, we want to rigorously. So the implant contains a small microprocessor running firmware to manage a whole bunch of its operations. And before we release it, starting off with firmware testing. So the implant contains a small microprocessor running firmware to manage a whole bunch of its operations. And before we release a firmware update, we want to rigor this rather inceptive image here on the channels. I'm going to hand it off to Josh.
Mechanical.
And digitize those neural signals and use digital logic to process and send out the bits we want for BMI. We also need ways to diagnose any issues with our electrodes and be able to drive stimulation engine to inject charge to the brain when required. Our latest chip is called N1 system on chip, and it is physically small, measuring only 20 millimeter squares or 4 by 5 millimeters. It is low power, highly configurable, and it has 1,024 simultaneous record and stimulation capable channels, and it has on-chip spike detection. To dive deeper into N1 SoC, I'd like to highlight 3 key innovations, and they are 1, analog pixel, 2, on-chip spike detection, and 3, stimulation on every channel. The first is analog pixel. Before we can convert analog neural signals into digital bits, we need to amplify and filter them. And this is where the analog pixel comes in. We want to have 1 analog pixel per electrode so that we can configure them independently. So in the case of N1 SoC, there are 1,024 analog pixels. Analog pixels also take up a significant portion of the physical space on the chip, and how well they work determines both the signal quality and the characteristics of the overall neural interface. The goal of analog pixel design is to make it as small as possible so we can fit more, as low power as possible so we generate less heat and have longer battery runtime, and as low noise as possible so we get the best signals. Now, the challenge here is that these goals are at odds with each other. For example, we want to achieve lower noise on the amplifier so that more spikes can be detected. But as transistors get smaller, it becomes harder to get lower noise while keeping the power the same or less. Since the start of Neuralink, we've gone through 3 major revisions to the analog pixel, progressively improving both the size and power while maintaining performance. Over the past 24 months, we had 7 architecture with detection. Spikes with actually identified differently characterizing the shape that we record. All-time spike detection. And it only takes, finally, it was important for us to do simulation in 8 micro and then time resolution. Each stem pulse, RMS just spike while only that can compress neural data more than 200 times, and finally, 4 by 5 millimeter silicon amplitude and 7.8 microsecond of time release. That big flip will tell you.
Thanks, TJ. That vision. Okay. So.
Mechanical packaging. So as you can,
Julian will tell us about how.
Battery manager. Implant controller. Coil antenna. Bam, bam. Temperature sensor. Goes into implant controller. Neural sensor, battery manager.
How we thermal to clean degraded performance. The electrical engineering team is currently engaged in developing a 3rd generation charger. Notable improvements include bidirectional near-field communication. This has allowed us to reduce the control latency and improve the thermal regulation. Improved thermal regulation results in faster charge times.
And now, Julian will tell us about how we test the N1.
Thank you very much, Matt. My name is Julian, and I lead the embedded software group on the Brain Interfaces team. So when we started building implants, we had a small manufacturing line, and to collect data from an implant, you would manually walk over with your laptop, you would connect, and collect the data of interest. But our goal is to make an ultra-safe and ultra-reliable implant. And so to do this, we scaled up the manufacturing line, our testing throughput, and data collection capabilities. So firstly, we added a large suite of acceptance tests to the manufacturing line. These test the functionality of each component and the final assembly. Implants coming off the line are then subjected to benchtop testing, accelerated lifetime, and animal models. We then collect data from these implants around the clock. This data is processed by a series of cloud workers and displayed in an aggregate manner. And then finally, all of this information feeds back into our design process and empowers our engineers to answer any question about any implant at any time. I'm now going to walk you through different parts of this infrastructure, starting off with firmware testing. So the implant contains a small microprocessor running firmware to manage a whole bunch of its operations. And before we release a firmware update, we want to rigorously test it with both unit and hardware in the loop tests, also known as hill tests. So to do a hill test, what you do is you instrument the battery, you instrument power rails, the microprocessor, and then we connect to each device with Bluetooth client. And then we walk the devices through various scenarios to test things like power consumption, real-time performance, security systems, fault recovery mechanisms, a lot of different things. In our original implementation of these systems, we used off-the-shelf components to start automating tests quickly. However, these systems were constructed in a relatively artisan fashion and were very difficult to maintain. And this meant that testing quickly became the bottleneck for development. So to alleviate this, the hardware and software teams developed a new system which integrates all the required components onto a single baseboard. We can then put the charger and implant hardware on individual modules that plug into this baseboard, including one board with opposing coils so that we can test charging performance. This architecture allows us to rapidly iterate different hardware prototypes because we can simply drop them into the system and reuse all the testing infrastructure. Additionally, we can host the current and next generation of our neural ASICs onto FPGAs and plug those into this board as well. And that allows us to test a whole extra layer altogether. So that's how we generated this rather inceptive image here on the right. What you're looking at is spiking activity emitted from some of our simulated neural sensors, streamed through the entire system over Bluetooth, and then displayed on a phone. This allows us to test everything in one system from chip to cloud. This system is 1/5 the cost, 1/5 the volume, and is very easy to manufacture. This allows every developer to have a personal unit on their desk, and it also allows us to shard the entire test suite over a large number of these units mounted into a rack. All of this has greatly accelerated our rate of development. Let's look next at how we monitor the implant's electronics, the battery, and the enclosure. So the implant will periodically capture all of its vital signs and commit those to flash. And then upon next connection with one of our recording stations, it will stream that data off. So for instance, if we look at humidity, we can get an understanding of the integrity of the implant's enclosure. And by looking at battery voltage and power measurements, we can gauge battery health. All of this is done automatically without any intervention, giving us 24/7 visibility into the quality of every single device. Additionally, we can use this infrastructure to request high-fidelity information on demand so that we can investigate different anomalous situations. So for instance, in this particular scenario, we were trying to track down the source of some spurious spikes that we were observing on different channels, and so we requested raw wave samples directly from those channels. Capturing good quality neural signals requires intact, low-impedance electrodes. And so this is also something we monitor very closely with dedicated circuitry on the neural sensor. So how do we do this? We do this by first using an onboard DAC to play a test tone on a single channel, and then we record, using our ADCs simultaneously, we record the response signal on both that channel and physically adjacent channels. Not only can we measure the impedance of every channel with this, but we can also map different physical phenomena to different characteristic signatures. So for instance, an open channel will appear as a very large response on the channel, and shorter channels will appear as a large response on neighboring channels. By looking at the purity of the signal coming back, we can also validate that the analog front end of the neural sensor itself is operational. In our original implementation of doing these impedance scans, it took 4 hours to get through all 1,000 channels. But by parallelizing the tests, downsampling, filtering, and then reducing the amount of information we have to stream off the device by moving a lot of the calculation to the firmware side, we're now able to scan all 1,000 channels in just 20 seconds. This means that we can run impedance on every implant every day, and then our internal dashboards can play back a history of this impedance so that we can get a really good quantitative insight into that interface between biology and electronics. Now that you have an idea about how we test and monitor our implants, I'm going to hand it off to Josh, who's going to tell you about how we get feedback even faster by accelerating our implants to failure.
As implants within it, it has been extremely challenging to design, build, and maintain a system of this scale.
That's probably the humidity sensor. That's probably the humidity sensor. Hoto, thank you for the follow. Hi Leo, what's up? Hello, hello, hi. Sharky Wave, hi Poto. How you doing, man? Orman, Orenby. How you doing, human? Human being. So this is considered a exposed pad W flat. And we're not using this. Is this actually what this looks like? I wonder. We were supposed to be looking for a different component, but I've pivoted to looking for this one for no reason other than I'm tired of looking for the other component and I cannot seem to find it. I'm fine. What about you? I'm doing well. I'm doing well. I'm a little frustrated because I'm trying to find a certain component on this board with very minimal information, but I don't even know like what kind of component it could possibly be. So if you know anything about microelectronic embedded parts, please let me know. I could use some help for sure. But I can't complain, man. I'm doing well. I can't complain, fellow human being. But I do not know what this looks like. Okay, we're gonna go back and then we're gonna zoop up here. Wait, this is interesting then. Why is it like that? It flares the other pads first before actually touching. So it flares this pad. Is there a capacitor there? Okay, there is. Oh, it is exposed. It is exposed. That's good to know. I would like to help you, but I am 300% more confused than you. That's fine. That's fine. Basically, I'm trying to reverse engineer this device. Essentially, this is the Neuralink device. If you've heard of Neuralink, it's the brain-computer interface company. It allows someone to control a computer with their mind, which is pretty cool. So there's a dude out there named Noland that can control a computer with his mind, which is pretty cool. And that's thanks to this little chip right here. This whole thing is no bigger than the size of a quarter, essentially. And so this is their PCB, or basically where all the electronic components are. And I am just trying to basically track down every single one of these components using nothing but this image and like another different really blurry image. I have like basically two really blurry images, and these aren't even real images, they're just 3D models, so it makes it even harder as well. But that is currently where we're at. We've tracked down a bunch of the big ones, but the smaller ones are proving more difficult for sure. So like this is the actual only picture that I have of the whole device itself. And honestly, it looks like not only are these exposed, but it looks like it's actually a lead. Oh, and how long have you been working on this? How long have I been working on the whole 3D model? For about a week now, I would say. And I'm barely really through it. But the hardest part is definitely finding these components for the PCB. Once I am able to do this, I am fairly confident that the rest could probably be done in another week or so. So, I'm getting through it. I am getting through it, slowly but surely. That is for sure. But yeah, it's important to me to find all of these individual components to try to make sure that this is as accurate as possible. Because I think that's important. So if I look at this big bar, then it kind of cuts out at the end. Is this what we're seeing here then? No, because this goes outwards there. So basically, this is like an X-ray view of this, so I can kind of see through the components to see how they're being bonded to the board. Essentially, these little like metal strips that you're seeing here are how they're actually attached to the board, and basically just off the general size and shape, and then the bonds to the bottom of the board are how I can tell what component is which. But it's hard, man. It ain't easy. And some of my endeavors have not been successful. Like, no, I won't do that. Remove this, and then let's just delete this. We'll delete this light as well. We'll delete, what is this? Oh, it's a camera. Is there no other image or guide you can rely on? No. Because this stuff is like, it's pretty proprietary technology. They do have a lot of information released on it, so I have hundreds of, probably like at least 100 pages of notes that I've written on a bunch of different things. Like this is just one note, and then I have a bunch of different notes that tell me more details about the device itself. But in terms of finding the exact components on the board, I just have these pictures to go off of. It's literally just these pictures right here. Just these pictures that I can zoom in on. So like, for example, this component took a long time to find because you can kind of tell that there's some text on here and there's this little dot in the corner. But, you know, without much else, it was like really, really hard to find. But I eventually did find it. Similar thing with this one. I matched up this little dot right here with this text, with this text, with this text. Even though you can't really tell what it is, you can tell there's 3 lines and a little dot. And then you can also see the number of like balls that are on the bottom here, and some of them are missing. So after a couple hours, I was able to find this one. I found almost all of them. If we look at this big picture, the only ones I have left are this one, this one, this one, and these 2 right here. But I found these are custom made, so I got these guys down. I got these little guys here. I got these guys here. All of these little guys are capacitors, so those aren't hard at all. I got this one here. I got this one here. I got this one here. I got this big guy. I got this little guy. I got these little guys on the side. So it's literally just a couple more. Definitely on the home stretch, I would say. I was hoping to try to get them all today, but it ain't looking like it at this pace that I'm going at. I would like to, but yeah. I should be looking at my notes, though, to see if there's anything else I can figure out about this. And I apologize for being washed out. I'm a white boy, so my screen is up at max brightness, so it washes me out. Washes my face out, for sure. So new architecture, ASIC radio, small power source under the Dura. Bigger battery, okay. Hermetic seal important. Excellent composition, yep, that's fine, that's fine. We don't care about this right now. McDougal isn't going to do anything for this. Compression challenge. It sounds very complicated. Oh, don't worry. Yeah, it's pretty complicated. It's pretty complicated, but it ain't that complicated. Basically, I'm just scouring the internet. Just scouring the internet for these parts. That's about how complicated it is. But finding the parts, that is definitely hard. That is definitely hard. Should theoretically be impossible. For a lot of them. But hey, with some time and good old ChatGPT to help you, anything's possible. ChatGPT has been super helpful for me, but it's also been super unhelpful at times. Okay, I don't think this has anything important. Let's look at this maybe. Charger 3D model at 10853.
How we monitor the implant's electronics, the battery, and the enclosure. So the implant will periodically capture all of its vital signs and commit those to flash. And then upon next...
That's not what I'm looking for. 114 is a... 114.21 is a teardown? Oh, but this is old. It's an old teardown. But this kind of looks similar to this, right? So this is what I'm looking for right now. It kind of does look similar to that. I don't think I can really rely on it though.
Scrappy. The system allowed us the fastest path to start.
It's not the same. Different models, yeah. Yeah, so this is from 2020. You can see in the top right corner, they had a whole different iteration, different prototype, so it's just not even, it's not the same.
Devices, tuning our working fluid chemistry, and checking third generation systems as the implement.
But I was thinking maybe that same part was on the new one, but I don't think so actually. No, we don't need that. That is the CAD model. It's red loops, custom chip. Custom chip. Oh yeah, that's that one. Imaging techniques. This is the fluorescence thing, right? Oh no, this is the micro CT. The X-ray view. Sharky caught. See if there's anything else that we have written down for this. We have 32mm power draw, electrode diagnostics, dedicated circuitry, that's fine. ARM processor, power consumption, real-time performance, BLE, transceiver, radio. Did I just write that down? Where did I get this from? BLE radio. BLE radio surface or SMD. There's too much information. Oh my gosh, the crazy part is that like anything that you look up, like I just look up whatever this was, BLE radio, which is basically just single Bluetooth radio, like something that makes your Bluetooth commit. But just look how much stuff there is. There's 800 results alone, and they're all super different. I mean, that helps for narrowing things down if you know specifications about it, but again, I don't have a lot of information to go off of, so it's like super, it's super hard to like, you know, narrow anything down if you don't know it at all. It's okay though, we persevere and we will find it. We will find it. I refuse to lose to the board. RF integrated circuits. Some good old ICs. Now the question is, do we have any 4-pin ones? No. Of course we do not. Alright, let's go back to what ChatGPT said. I feel like ChatGPT, power electronics antenna, on plastic, structure support, do research, make us a voltage regulator, step up, step down, that's fine. Ferrite shield, hardware notes, temperature sensor to measure humidity, which I believe is this thing, which makes the most sense. Humidity. Or temperature sensor to measure humidity. Battery voltage and power measurements. BLETR somewhere. need this anymore because we found that eventually. What is this? Oh, that's their paper. That is their paper. All right. I know I'm jumping around a lot, but okay. Let's look at what ChatGPT was saying. It thinks it's possibly compact ceramic or metal resonators are using the timing. Okay. Check manufacturers like Epsilon. Okay, we're just gonna go to DigiKey. Resonator DigiKey. Oh, I mean, they just look similar to oscillators, low key. Low key, they look exactly like oscillators, but no. So, for example, I look at this and you see like the 4 gold prongs sticking out. Well, what we're looking for is I gotta go back. We're looking for this weird design. So it's 4, but they're little square corner pads, and then there's like some diagonal connecting the two, which I'm very confused about that, to be honest. I'm not sure how that plays into the design, the diagonal specifically. But I can just tell by looking at these that, you know, it's not going to be our guy. But we can show 100 on here, and we can keep looking. It's interesting to switch to. It's like a saw resonator. I was looking at that before, but I think this is probably too big if I had to guess. It's 3.2 times 2.5 we want. Yeah, it's too big. Too big. For me, most of them look alike. Yeah, they actually are. Most of them are the same. So if you notice, they're all like R03104. So they're actually all the same line. There'll be like one small thing that's different. So like this is 4A probably because it has 4 amps. This is 8A because it has probably 8 amps. But I'm telling you, you're so right. Like in terms when you're saying there's too much information, there's like 10 different models of this literally the same exact tiny component that will have like one slight difference. They have to make a whole new model for it. So stupid. So that's why usually when I just see like a new picture, that's when I like pick it up and I'm like, oh, okay, maybe this one is different from the other ones. So like, look at all these. These are all the same one. They're just slightly different. Not even. 950, 350. It's so stupid. So stupid. I should be filtering by size. Low key. Okay, so we're looking for 2.2 times 1.8. That's not even an option. We can maybe do this one, but yeah, it's just not even it. It just ain't even it at all. I'm not sure why it's like switching between dark mode and light mode. That's a little weird. Alright, so I don't think it's a resonator. It could be MEMS. Oops. MEMS component, DigiKey. Could be a MEMS oscillator. It could be, but unlikely. But we want to look for 4 connections. So 4 SMD. SMD meaning surface mount. So that it just sits on the surface. It doesn't like go through the board or anything. Surface mount. And we can do this one and this one. How many results are there? Still 77,000 results. Okay. But we want to look for something that's shielded because it's metal. But I don't even know if that's an option here. I don't think so. So maybe we can just do the size again. Okay, so 2.3, 1.8, 2.3, 1.8. Nothing really matches here, but we can maybe look for this and this. Okay, that's 16,000 of them. Jeez. Okay, what's the height? That's a good question. Point or like 7. Maybe this one maximum. So that's still a lot of them. But these are all. How long have you been making 3D models? I just learned last week, about 9 days ago or so. And I built donut. You want to see my donut? I'm sure you've heard of the famous Blender donut tutorial on YouTube. But yeah, here's my donut. So this is the only thing that I've ever actually like completely modeled. Oops. Yay, donut! I tried to make everything like a blue theme to it. But then this is my render too. So this is like the still image capture of it. But yummy donut. Even though it kind of doesn't look real. The donut doesn't look real, but my first ever time doing any of it. Low power programmable oscillator. Oh. Are you metal? Are you metal? No, you're not metal. And you also have bad pads. OMG, I love it. Thank you. Yay. Yeah, I like it too. I think it turned out really well for my first ever component. I'm satisfied with it for sure. See, I want to I can't just get through all these MEMS oscillator because I need it to have a shield. So like shield. Nope, undefined. So metal. Okay, what is a MEMS resonator? Is that even a thing? No, it's not a thing. What do you like to do? What are your hobbies? Are you a 3D model at all, or? I'm so tired. It's 5 o'clock. Keywords. MEMS resonator shielded 2x2 pad. That's not a thing. Oh, unless. I mean, this is the closest things I've seen. It's not even remotely close, but you know. I guess it's kind of getting there. What the model look like? See, these are just jumping back to oscillators. I don't want to jump back to an oscillator. Oh, this is an oscillator. Is that why it looks so familiar? Maybe it is just an oscillator. I don't know. I usually practice musical instruments or try to learn new languages, although I easily get confused and give up. Same. Not musical. I used to play a bunch of musical instruments. I used to play like violin and trumpet. I used to like sing and do handbells and a little bit of piano, but nothing crazy. But all that sort of jazz. But that was, when I was in middle and high school. But yeah, I used to be fluent in Spanish as well, but I don't remember any of it now. I went to Europe like last year, and I could not speak a single sentence while I was in Spain. It was bad. And then I went to Japan, and so I learned Japanese a bit, and that I've held on to a bit. Like I can read hiragana and katakana and some kanji, but like not a lot, and I'm nowhere near fluent. But what about you? What languages do you know? And what instruments do you play? Or have you been learning? Anti-vibration bad?
Hello? I mean, automated grade long Bluetooth. But look how many connections that is. There's no way any of this is only 4 solder pads. Spanish will just happen. This happens that my native language is Spanish. Okay. Me trying to think of a Spanish sentence in Spanish. I probably can't think of anything, to be honest. Yo quiero ir a la playa. That's all I could think of. But yeah, no, I learned Spanish from when I was 5 in kindergarten all the way to when I graduated high school. So for a very long time, like over a decade, like 13 years or so. And then I went to Guatemala and spoke fluently there, and it was awesome. And it was so cool to interact with everyone and like completely understand the language. And then after that, I went to college and I stopped speaking. And then here I am years later and like completely lost all of it. Completely lost all of it. But I love Spanish. Spanish is a beautiful language. It really is. Me encanto español. Right? Isn't that how I say that? No, me encanto is like I love to me, right? So it's just encanto español. I'm so bad, and I sound like a white boy when I talk too. I used to have a decent accent as well. Maybe it is wireless radio module. How did I stumble upon this? I would prefer not to sign up to download. Spanish is a very beautiful language if you remove the huge amount of rudeness or curses. Yeah, that's fair. I love the upside down question mark and upside down exclamation point. I think it's amazing. I think it's so cool. I love the double L's too and rolling R's. Perro. We don't got that in English. We just suck. Well, I'm even looking at this though because like high key, there's no way any of this is outputs from 4. How did I even get here? I looked up MEMS resonator shielded 2x2 pad. RF MEMS switch 2x2 package. Optical switches? Nah, ain't no way, bros, on optical switches. We've gone so far to the point of optical switches. It's 4 pads. It's just an oscillator, surely, right? When I was learning English, I forgot it. I found it strange that there was only 1 question mark. No, trust me, you can add more question marks to the end of the sentence, and it conveys a higher sense of confusion, you know? Like, what are you doing? Question mark, question mark, question mark, question mark. But yeah, no, I know what you mean. That is funny. How do you denote the beginning of a question if there is no upside down question mark? What's your favorite language? What is your favorite language? Where's medical device? I don't want the optical switch. Get me out of the optical switch rabbit hole. Why does it keep bringing back? What if it is just a crystal oscillator? Nothing I am finding is four square 2 by 2 pats at all. None of it makes sense. I am very lost. I tried everything you told me to, and I could not find anything. Would you like to search? I can turn it on. English is my favorite because it hasn't been that difficult to learn naturally, but in other aspects, probably German. ChatGPT, our savior. I know. ChatGPT has been so nice to me too. Yeah, English is nice, but I think Americans take it for granted that we just, like, literally, we literally don't know any other languages because English is just like the universal language. But yeah, English, I guess, isn't too hard in comparison to other ones. German's funny. When I was in Germany, I just couldn't help myself. I'll just laugh just because it's just how some of it sounds. It just sounds so funny. I love it. 1, 2, 3, 4, 5, 7, 8, 9, 10. Completely understand how frustrating this will be. Yes, if you like to try and search, I'd be happy to take a fresh look for you. Okay, what do you think it is? Download the Chrome extension to switch your default search engine to ChatGPT. Interesting. Crystal Oscillator by Seiko Epson. Yeah, wait, give me this one. Yeah, I mean, I was thinking that it might be something like this, but it's not exactly what this looks like. This doesn't look like exactly like that. It's too different. The soldering pads aren't square either. Or I mean, I guess they kind of are. And like, if I look at the video that I don't have pulled up because I am a stupido. Estoy estúpido. I want to pull up. What am I doing? What am I doing? To me, they look the same. I mean, it is possible. Okay, so here. I'll tell you why it doesn't look the same to me. Okay, so if we look at, like, let's do the other one. This picture here. Okay. This right here is a crystal. It looks exactly like this that you're seeing up here. And you can kind of tell because you can kind of see a little bit of silver, you can kind of see a little hint of gold, and then it kind of drops off there to some sort of like normal packaging right here. Here is also something similar. This is called an RTC, or real-time clock, but it looks very similar. Now, if you notice, this is the component we're looking for here. This component, it's way too silver. Like, look at how metallic the top is compared to these. These are kind of like a matted silver on top, right? Or silver or gold sort of thing. And then you have this gold outline. There's no gold outline here. It's like this little metal box that sits in this other metal container on the outside here, that is also silver. And then on the bottom, bottom, so here you can even see like the metal outline of it. Okay, can we go back? I don't know why the video gets pixelated like this. It'll fix itself. So here's the top of it, right? And then it kind of flushes out, and that's the side of it. And then it expands to this wider bit here. And then there's the soldering pads. So the soldering pads look like something that would be from a crystal oscillator, because normally there are 4 soldering pads like that. So maybe it is. Maybe it is just a crystal oscillator, but it just, I don't know. What about this one? See, like, just the look of this just doesn't sit right with me. Because if you look at this, it's just, this is not that. It's just not. It's just, this is too sharp. It's like this should be like a rounded out box that drops into this other box, whereas this kind of like rounds out by itself. Won't it be more than one piece, or I'm just delusional? I mean, that's like another great question too. I can't think of what would be 2 pieces like this. The only thing I can think of is that this is a dip going into a dip to surface mount thing, but no, I mean, I don't know. It could be, I guess it technically could be 2 separate pieces. I don't even know what to look for though, if it's 2 separate pieces like that. Maybe I can ask ChatGPT. This also says an RF filter, but then it gives me a crystal oscillator as an example. So if I take this image and I give it back to ChatGPT, which I've given it a bunch of times, if you look at, here, let me draw on it so it can kind of understand what I'm saying. I think it helps better when I draw at it. Draw on it. Edit. Good old paint. So it kind of looks like it drops into here, and it goes around like this, and then it goes back like this, and like that. So this is kind of like the 3D view cross-section of what it would look like. And then in like blue, maybe, then we have this thing below it. So it kind of like curves around right here. Comes in hot around and disappears that way. Loops back around this way. You think that's good? You think ChatGPT will like that one? Ted. Sure, that's fine. Alright, let's give him Ted. If you look at the picture again, it almost looks like it's 2 components sitting on top of each other, question mark. The metal box that has rounded corners, rounded edges, and is very shiny, sitting on top of less shiny, like how would you describe this? Less shiny, not tall, but wider container. I forgot to say that I like circled it, but two layers or components stacked together is a game changer. Let's go. Let's go. Potosuki. China mobile exercise is like the functional component in your oscillator RF module. Its shielding suggested preventing bottom layer, the wire short container might be part of the mounting mechanism or integrated. Like mounting mechanism could be, I guess, or integrated part of the package could be a base plate for thermal management or mechanical stability. Alternatively, could be an electrical ground shield. RF module with integrated ground plane. Advanced oscillator with integrated power regulation or frequency calibration. It's not custom. It's not custom. Sure, go for it. Drawing it worked, I think. I don't know. It's pretty smart nowadays. It can take the picture and just kind of understand what's going on. I've been doing that for a bunch of other parts too. Like I've been attaching pictures, and it's actually been really good at like identifying parts and like understanding the connections between the two and things like that without me even really saying much, besides maybe like circling some things. It is not an RJ45 connector. No. The component in question appears to be a shielded, stacked 2x2 RJ45 connector. That's literally for Ethernet. These connectors are commonly used in networking equipment to provide multiple Ethernet ports in a compact form. This thing is not Ethernet. It is a Wi-Fi based product. That is hilarious that it thinks that. Okay. Jeez, I cannot trust the search. That is funny though. That is funny. Example, the HJ2 by Halo Electrons is shielded stacked 2x2. I mean, they're not wrong. It is shielded and stacked and it looks like this, but I think we're missing the goalpost here. If it wasn't RJ45, imagine. Even I know that. Yeah. And literally, this is like a completely Bluetooth thing. The whole thing is the size of a quarter. Imagine trying to put an RJ45 port on that. That would be crazy. Okay. Definitely not an RJ45 connector. The whole PCB is the size of a quarter, and it is completely wireless, remember? The size of the component is, what do we say it was? 2.3, 1.8 times 1.8 times 0.7. I have a confidence search was about that. That'd be a hell of a port sticking out of your head. Good for LAN purposes, though. True. That's right. I forgot if I'd be completely out of place. Given the size file design. Okay, let's go back to the core design. Let's not further. Okay, we know that the spam is a stacked or dual layer design, top middle shielding with rounded edges, bottom wider and less shiny, possible structural or thermal base. I like that. I think it is a structural or thermal base. Like some sort of intuition that I have is that it is a structural thermal base, and maybe that is the and that is the crossbeam that we're seeing here on the diagonals, right here. It's probably part of the thermal structural design. Okay, so near the microcontroller and inductor. Reassessing likely candidates, metal shielding points to RF or high frequency component. As oscillators, RF filters are balance. It really is stuck on RF filters or balance, but I can't find anything about, I mean, shit, like that one looks good. I mean, it's not right, but nah, it like can't be this, but it's like, it's not a terrible. I mean, these are the ones I was looking at from TDK, but it's definitely not from TDK. I do not see a black screen. it would be very, very obvious. Here's the other thing too. Okay, RF filters are Balin's 2 by, what was the 2 by, or 2.3, 2 by 1 by 0.7, 2.3 by 1.8 by 0.7 millimeters for SMD. See, like, nothing comes up now. Nothing comes up now. So I just don't, I do not understand, man. Why are you giving me so much pain and trouble? Why do you cause me pain so? SMD balins and bandpass filters, and that's what we get. Murata, you motherfuckers. It's part of my language. It just ain't this, no? It just ain't looking like that. Is it just an oscillator? It might just be a crystal oscillator. Why though? Why would you need another crystal oscillator? It does not make sense to me. Stack construction site, either integrated module with multiple functions, oscillator with power conditioning, custom assembly with the base but supports thermal electrical needs. Says and pads point to simplicity with only 4 connections. Straightforward function, yeah. Timing, oscillator, resonator, signal processing, filter, or balun. RF filter. No. Why would it need to be a filter? Okay, can I ask you something? Can I ask a clarifying question? What exactly would be the inputs and outputs of said RF filter? The analog input signal from the device is amplified, filtered, and ADC'd on the ASIC, the custom ASIC that they have. So what more RF filtering would be needed if the data is already digitized? It's also an already filtered ADC'd and thresholded to spike to neuronal spike data on the custom ASIC they have. So what more RF do we need if the data is already digitized and compacted into a small form? What exactly would the RF filter be doing? Does it have something to do with the BLE protocols from the microcontroller? Let's see. Come on. Rolling the dice. Feeling lucky. Exclamation point, 8 balls in chat. Alright. Purpose of RF filtering. In general, RF... Oh, okay, I thought that was it. Okay. In general, RF filters are used to remove unwanted noise or signals outside of a specific frequency band, high frequency interference, match impedance, and wireless communication circuits, ensure compliance with electromagnetic regulations by cleaning up transmitted signals. Okay. However, for Neuralink system, this raises valid concerns. My brain is not braining. It's okay. right now there's nothing important to be understanding because I'm just trying to figure out and get to the bottom of this. Signal path already digitized. As you mentioned before, the analog signal is processed on ASIC. RF filtering in BLE context. If this component is associated with the BLE protocol in the microcontroller, the RF filter was used to serve a different frequency outcome. Clean up the BLE signal before it reaches the antenna to remove spurious emissions or harmonics. Removing noise from received BLE data to ensure clean input to the microcontroller. BLE modules often have integrated filters, but in some cases additional filtering. Why would Neuralink need this? Antenna isolation. If the PCB uses a compact internal antenna, additional RF filtering might be required to handle signal reflection or interference in such a small place. I think they're right. I just cannot find it. BLE communication must meet strict FCC. Yep, that's fine. Ultra dense design. The dense placement could crosstalk even fully digital. Okay. If not RF, then what? Then oscillator resonator could be time related. MEMS RF switch used to route BLE signal between different antenna paths or for specific transmission modes. Thermal management or ground shield. The lower base could be primarily. Okay. Final thoughts. If this component is involved with BLE, an RF filter for the microcontroller could be considered plausible. However, BLE doesn't need additional filtering. Would you like me to refine the search based on BLE specific components or explore aspects? Can I give you the RF data sheet and you tell me what kind of RF filtering would be needed? Is there anything else you would need me to give you to help determine? Okay. Let's find that in our data sheet. We have it right here, and I believe it's this one. Yeah, product specification, right? Because this one is just the... Okay. Where are we at? Yep, absolutely. Probably with that. I would analyze pretty quickly. Here's what I'd look for. Internal RF runners already have RF integrated with valence or impedance matching. If yes, antenna design, output, BLE specifications, alignment. Antenna design documentation. Does Neuralink board use specific type of antenna, PCB trace antenna? Okay. I attached 2 documents. One for the data sheet, and the other is, I don't know what you would call it, more general sheet about the NRF. Bam, bam. In terms of antenna, I believe either the gold traces that go around the whole PCB could be the antenna, or it is part of the power electronics on a different PCB that we haven't even gotten to yet. Why can I not send? Hello? File upload pending. Is it a big boy? Is that why? Oh, we're good. Okay. Regulatory considerations. If you have any documented insights on the board's target region, FCC. Okay, for sure, I know they need to pass FDA protocols, and I would guess maybe FCC 2? Come on. Give me something good. Reading documents. That is to say clean and interference-free RF operation. Well, the on-chip Balun of the RF provides single steps implying single additional if it could be critical in high-precision application. Okay. Antenna isolation. The filter might also serve to isolate the antenna from potential noise sources on board. If the antenna on the main PCB, the gold traces you mentioned, is integration with an RF micro additional filtering. Okay. If the device uses BL extensively, a 2.4 GHz band can be noisy and external build filter. Examine the traces connected to the component to confirm its connection to the antenna or RF lines of the NR. The traces are hard to see with the NRF because they are so dense and the solder balls get in the way of the only X-ray images I have. Is there a specific pin off the NRF that you found in the data sheet that I should be looking for traces? Honestly, I don't know what the antenna would look like. When I did basic Googling, it seemed like just some exposed traces on the PCB itself, which is why I presumed the giant gold traces around the PCB. See attached picture would be the antenna, but I could very easily be wrong, so let me know what you think. Okay, and then we're gonna go to here. How long did it take you to make the donut? It took me 2 days, basically. So the first day I spent most of the time modeling and a bit of compositing, but then the second day I spent most of the time like learning geometry nodes and setting up the shot and then rendering. So by the end of the second day is when I had that video. Okay, let's see. What do we want to find here? We want to go here and we want to give it like this image. See attached. Whoa. Images. And this one. Okay, please give me something good. PCB antennas are indeed often realized exposed traces designed to resonate a specific frequency of the gold traces, and it could be an antenna, especially if they form a loop or a specific pattern optimized for BLE frequency bands. However, antennas typically need a direct RF signal input-output. These traces could also serve as ground planes or shielding for the PCB. Look for connections via tracers between the gold loops and the RF output pin of the NR. Okay, that means we got to pull up the data sheet for this. Hi, Sylvia. What am I asking ChatGPT? It's a long story where basically I'm trying to find this one component on this board here. So this is a picture of Neuralink's board. So Neuralink is like the company that you can like, they put a brain implant in you so that you can control a computer with your mind, which is pretty cool. And what I'm trying to do is reverse engineer the whole thing. So all I have to go off of is basically these, just a couple pictures, basically this and this, which are 3D models, not even pictures of the real device. And then I gotta try to find each individual components. Okay. Yeah, I know Neuralink, isn't it Musk's? Yeah, and Musk founded the company. He's still a part of it, but it's definitely his most hands-off company. He probably only shows up like once every couple months, and then asks to be filled in on it. It's mainly run by this guy named DJ Sao, who's really good. So yeah, I'm not the hugest fan of Musk in recent times, obviously. So Not really there for him. There for the company itself. Yeah, I guess he's onto X and Tesla the most. Oh yeah, for sure. And yeah, he's not even like really in SpaceX too much anymore. It's mainly Tesla and X. It's mainly X. Let's be honest. That guy's tweeting 20 hours out of the 24-hour day. So, anyways, I'm really passionate about Neuralink, so like I want to reverse engineer it. So I'm trying to have ChatGPT help me with this one specific part, but it's really hard to find this part. The gold trays around the edges could be antenna, especially if they form a loop or specific pattern. These trays could also serve as ground planes or shielding. Okay, look for connections. Oh yeah, okay. So we want to pull up this document, which we pulled up 4 times now. Jesus, is amazing. Okay, package. Yeah, let's go here. And the rocket ones. Yeah, SpaceX and Starlink. Starlink is a subsidiary of SpaceX, so they're technically the same company. Where are you from? I can't understand the accent. Do I have an accent? I'm just from the U.S. I'm from Pennsylvania originally, but I've been moving around for the past couple of years. Like I've moved all across the country. I lived in Boston for a bit, and San Francisco, and Phoenix, Arizona, and Texas as well. So, oh, okay, cool. I'm from Italy. Oh, that's sick. That's sick. We're in Italy. I was just in Italy last year. I was in Venice, Florence, Firenze, right? That's what it's called. And Roma. And I had a buddy that I stayed with in Rome, and he taught me some Italian, but I forget most of it now. Grazie mille. Was that good? No. Okay, I'm sorry. I am sorry. I'm sorry for that. You're from Rome. Oh, so you were in Rome. Cool. Yeah, Rome was sick. Rome was awesome. I love the Roman Forum. It's actually probably one of my favorite places that I've ever been. Just how old those buildings are. I mean, every building in Rome was older than any building here in America, you know? So, yeah. And obviously Vatican was beautiful, and Trevi Fountain, all that stuff too. But the food was amazing too, because I had my friend, he was able to bring me to some local places. So I got the authentic carbonara, all that sort of shit. It was delicious. It was delicious. I'm from Rome. Oh, so you're Rome. Cool. Yep. That was good. That was good. Don't worry. No, it's okay. I know it wasn't good. You know, I appreciate you, but that's. I was just fucking around. Do you have TikTok? I do have a TikTok that I just created for this account, but it has nothing on it. So just don't expect anything crazy. But I should actually link it to my stream, my YouTube as well. Let me go full screen so I'm not leaking anything real quick. Select 2 objects that are the same shape. Okay. Weird flex, but okay. Drop the handle. Yeah, I'm pulling it up. I'm trying to log in. There's nothing on it. So, but yeah, please feel free to follow. I'm definitely gonna plan on posting some once I kind of get this modeled and I can start doing like my YouTube videos and things I want to do. Okay, here you go. Pasting in chat. What's your favorite part about Rome? Why is it doing this one? What is going on here? Give me a second. It's like make me Okay, whatever. Life, I cannot whisper you back for some reason because my account's not letting me to. I'm not letting me. followed you. Just curious, how old are you? Part as in what part of the city? Yeah, as in like what part of the city? I'm older than you would think. Would you guess my age is? What would you guess my age is? Trastevere is my favorite. I don't know if I know that. Oh yeah. That's the No, actually there. That's like where all the nightlife is, right? Like it's like where all the bars and all the like fairly young people go out, shit like that. 22. You're close. You're close. Like, feel free to whisper me the reason why you said that. I can't whisper you back for some reason. I don't know. I don't know why it's saying that, but I am curious as to why you said that. Basically, yeah. Okay. What do you like about it? Is it the fact that it's like that it is like for young people, like out in nightlife, or what's cool about that area? Okay, what am I doing here? We're looking for the specific pin that is the RF pin. So if I just search this, I'm sure, yeah, wow, 300 times, okay. No, package. Okay, this is the pin output, right? Okay, yeah. So we want to look for the RF output. Leia, don't be mad at me. No, it's being on the river. Yeah, okay, that's true. That's fair. That's very fair. RF. Leia, stop. We'll talk about it later. It's not a big deal. Okay, I literally cannot find where RF would be here. Literally, I'm looking at all the pins. Oh, this one. Antenna. Single-ended radio antenna connection. Okay, E1. E10 these nuts. Oh. E1. Okay, it's the first one next to the... closer to the inside, right? So it's... yeah, E1 on the inside. Okay. Okay, so it's this one, right? Yes. Okay, so we want to look for this connection, see where that goes. Doesn't even have a connection. Oh, it does. What is this? Oh, interesting. Very, very interesting. So that means that there is an antenna externally, right?